Hello, everyone. In the 9.1 extension lesson, we're going to be covering two topics. We wanted to show you kind of where you might see some square roots, and so this would be very common to see in particular a geometry class, which you'll have next year. And then down below is the cube roots. So we didn't get to rationalizing cube roots in our 9.1, so we thought we would just go a little bit further here in our extension lesson. So please remember that this is an extension, which means it's not required. There is no exit quiz, but it definitely is helpful, okay? So in the first two problems, what we're going to do is we're going to use Pythagorean's theorem, so a squared plus b squared equals c squared, to solve them, and we cannot put them in decimals. So if you remember with Pythagorean, the two legs make up your A and your B. Now it doesn't really matter which one's which because we're going to add them together, so that doesn't really matter. And then this one we typically call our C, okay? So if we use Pythagorean theorem, we're going to go 5 square roots of 2, quantity squared, plus 7 squared is equal to C squared. And so what we just kind of wanted you to notice here was, how do you square a radical in this particular sense? And we can't go decimals. So what we'll do is we're just going to duplicate this parenthesis out. So it's 5 square roots of 2 times 5 square roots of 2. And so if you remember from back in 9.1 here, we do outside times outside. So 5 times 5. And then we do the radical times the radical. So 2 times 2, which would be 4. And so we're going to clean this up in just a second. But let's go ahead and work this one out. Now this is just a whole number, so we can just square it. So 7 squared is 49. So that's not too difficult. Now in this one, the square root of 4 is really 2. So if we go ahead and just think of this as 25 times 2, we get 50 plus 49 is equal to c squared. And now if we add those together, so 50 plus 49 would be 99 is equal to c squared. And now to get the c alone, we would need to take the square root of both sides. And so the square root is going to cancel the square. But now if I move over here, we need to basically work this out, the square root of 99. Now if we were to grab our calculator and we were to type this in, the square root of 99, notice we would get a nasty decimal. And in the directions up here, it tells us we cannot have decimals. And so we need to break this down without decimals. And so you need to think of the two numbers that are going to multiply to get 99, that one is perfect. And so again, if we were in class, I would ask you, but since we're not, hopefully you're thinking 9 times 11, okay? So if we think of this as 9 times 11, then the square root of 9 is going to come out because it's perfect. So the square root of 9 is 3, and then the square root of 11 we can't do anything with, and this is the answer for the missing side, okay? So you're going to see these things again, particularly a lot in geometry, and there's another place where they come up in geometry, just besides right triangles and stuff like that. But we just wanted to give you a couple problems that you feel comfortable with, that you've seen Pythagorean before. So if you want to give number 2 a try, if you want to pause it here and try it, because it looks a little nicer, but see where the radicals pop up. All right, hopefully you've paused it and tried it. We've got our A and our B and our C. And again, remember that the order of these two is not going to make one bit of difference, so it doesn't matter. So we're going to go x squared plus 8 squared is equal to 16 squared. So I have 8 squared is 64. Now I don't know 16 squared, so let me just type that in my calculator. I get 256. And now I'm going to subtract off the 64. So I have the x squared is alone, and then if I subtract, that would be what, 192, okay? So let's just so to get this alone, we know we're going to have to take the square root of both sides. So we know that the square root and the square are going to cancel each other off. And so we know the x is going to be alone, but let's just take our calculator and just try it, 192, and let's just see. So we know it's not perfect. But now we need to think of the combinations that make this up. Now over here, 99, I could physically see the 9, so it's a little bit easier. But in 192, you might not know what makes up 192. So if you remember your perfect square list, so I'm going to kind of start up here and work backwards. 10 squared is 100. Okay, I know that 192 is way down here, but I highly doubt it's going to be anything above that. So let's kind of work this way. So that's 10 squared, 9 squared, 9 squared, 8 squared, 7 squared, 6 squared, and let's see if we can get one of those to hit, okay? So let's take 192 and let's divide by 81. So 192 divided by 64. Look at that. Now, is there something smaller that would go into 192 that's a perfect square? Probably, but if we use it, then we know we're going to probably have a hidden. So it's always better to go with the bigger perfect square numbers than to start on the other end. So you don't want to start down here at 4. That's going to cause problems. You always want to start on the higher end and work your way down. So now the square root of 64 is perfect. So that's going to come out as our 8. And then the 3 is left over, and so it's going to stay under. And there is our missing side. So if you noticed at the beginning, this problem did not look like it was going to have radicals involved. But notice how our answer works out, okay? So that is just one application that we wanted to show you, just kind of where you're going to see these things and how they work. So remember, in algebra class, a lot of times we just kind of teach you the skill. But then when you get to geometry, maybe when you get to science, you're going to use those skills to solve more real-world problems, okay? Now, we're switching gears here, completely switching gears. So now we're going to cube roots. We're going to try to simplify with cube roots. So let me grab a piece of paper and just kind of cover this up for a second. And let's write down the perfect cube. So if you remember, I showed you this before, you can go to your calculator and under the y equals, you can type in x cubed and then go to the table. And then the table will give you the perfect cubes. So I'll just write a few of these down. And one isn't going to do anything. So if you want to skip that one, you can. We've got 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed. And I don't probably think we need to go any higher because if you look at our numbers, notice we have a 4, a 5, and a 16. So I don't think we need to go that high. Okay? Now, when you look at this one, this is very similar to rationalizing. The problem here, and I'm switching to a pencil, the problem here is if we try to do our typical rationalizing like this, if we try to do that, when we multiply on the bottom, we're going to get the cube root of 16. Look at my list up here. Is 16 a perfect cube? And the answer is no. So cubes are a little bit tricky. With cubes, what you need to do is you need to make this a perfect cube. So you have to ask yourself, what am I going to multiply 4 by? What am I going to times this by to get to a perfect cube? So what I do is I take this number and I look at the list and I say to myself, okay, 4 falls right here. What can I multiply to get to this perfect cube? And so the answer is, well, I just got to multiply by 2. So if I multiply by 2, then 4 times 2 would get me an 8. And then if I take the cube root of 8, I would just get plain old 2. So now look at how nice my denominator is. Do you see how it's nice and cleaned up? So I know this is the correct number to use when I rationalize. The only problem is whatever you do to the bottom, you just have to do the top. Because remember that this has to be equivalent to 1. That has to be equivalent to 1. So whatever you do on the bottom, you've got to use the same number on the top. Now when we multiply these together, that's 7 cube roots of 2. So we have 7 cube roots of 2. Well, there's not really much to do here, so you just move it over. 7 cube roots of 2. And then you kind of just go through a couple of your questions. Do you have a radical here? No. Are these as low as they can go? Like, could you reduce them? No. Is this as low as it can go? Yes. So now you know you're done. Okay? So cubes are a little bit trickier. So let's take a look at number 4. And remember, at any time, if you want to pause it, you are welcome to hit pause and try it on your own first. Let me just write it down here because this might kind of get in my way. So I'm just going to recopy it. Now again, think about if I were to times this by the cube root of 5, that's going to get me the cube root of 25. But 25 is not a perfect cube up here. So that is not going to help me. So I need to ask myself, what am I going to multiply by? What do I multiply by that's going to make this perfect? So go up to your little list here, and 5 sits right there. Can you multiply anything times 5 to get to 8? And you're like, no. Can you multiply 5 anything to get to 27? No. How about 64? No. How about this one? Now remember, 5s only go into numbers that end in 5 or 0. So do you see how this ends in 5? Now you might not know what the number is. So if you go 125 divided by 5, it's 25. So if I go 5 times 25, I get a perfect cube. So I want to put a 25 right here. Because then when I multiply these together, 5 times 25, I get 125. And 125 is perfect. Okay? So the bottom is going to clean up to just be plain old 5. Because I know it's perfect. But whatever I do to the bottom, I just have to do the top. So I'm going to put 3 cube roots of 25 here. And notice I'm just going to kind of push these together. So 6 cube roots of 25. And then nothing really to do because this is only made up of 5 times 5. 25 is a perfect square, but we're dealing with cubes. So 25 cannot go any lower. And once again, just quick ask yourself, do you have a radical here? Can these be reduced? Can this go any lower? And once you've kind of cleared up those 3 questions, then you know you're done. Okay? So I just have one more, and really this one, a couple differences. One, it has a variable in the denominator, so we thought we'd throw one at you like that. And notice now we have this cube root over the whole thing, the top and the bottom. So if you want to give it a try, again, you're welcome to pause the video and try it on your own. But this is the last one we'll go over for the extension. So what we have here is a fraction. So what I would recommend to you is try to simplify. So can you reduce these? And the answer is no. So then you just have to split them apart, just like we did when we were dealing with square roots. So we're going to split them apart. Well, look at the top. I mean, we don't always write it, but what's the cube root of 1? Isn't it just 1? So look at how nice the top cleaned up. So that actually worked out pretty well. Now the bottom, I know 16 is 4 times 4 or 2 times 8. So if you want, I could try to do that. But that's going to still leave me with this underneath. So how about we just leave the 16 alone for a minute, okay? Now, we're going to rationalize. So we know we're going to multiply by something on the top of the bottom. And this is going to have to equal a perfect cube. So remember, same question. What are you going to multiply by to get a perfect number right there? You got to have a perfect number. So let's see where 16 falls. So if we go up here to our list, 16 is going to fall right here. Now, I don't really think there's anything I can multiply 16 by to get to 27, but maybe I'm just not sure. So instead of going like this and trying a whole bunch of combinations, sometimes it's easier just to go 27 divided by 16. And if it comes out a decimal, then you know that's not an option. So then again, 16 times what? Well, there's a bunch of 6s, so maybe this is going to work, but why don't I just go 64 divided by 16? And notice it's times 4. So if I times this by 4, that means I'll get to a 64, and 64 is perfect. So the cube root of 64 is just 4. But this time I have a variable. So what you have to think about is it's a cube. If you're taking the cube root of x, How many do you need down here? How many do you need to come out of that radical? You only have one. How many more do you need? And so hopefully you're saying you need 2 more because you need groups of 3. So if I have 1 and I add 2 more, then that gives me x cubed. And when I take the cube root of x cubed, I get x, okay, because I have 1 group of 3. But remember, whatever I do to the bottom, I have to do to the top. And so 1 times this isn't really going to change it. It's just going to kind of move over. And then just be really careful. Our eyes are so used to seeing this as perfect. It is a perfect square, but we're dealing with cubes. So the top is done. Now again, many of you may want to try to reduce these, but the cube root of 4, so if I do the cube root of 4, notice it's not the same value, okay? So don't let your eyes be tricked. This cube root is affecting this top number, okay? So that concludes 9-1, and this was just, again, a little extension of a few topics that we didn't get time for.